Okay, today's lesson is 3.4, power of a product and also power of a quotient. Now, product is an answer you get when you multiply. Quotient is an answer you get when you divide. Your I can statements are, at the end, we want you to be able to say, I can determine the properties of integer exponents by exploring patterns and applying my understanding of properties of whole number exponents. Also, you're going to be able to hopefully say, I can use the properties of integer exponents to simplify expressions. All right, starting off for the notes, expanded form. Now today, we have the parenthesis xy cubed. That means we need 3 of each of these. If I were to write that out in expanded form, really that means x, because if they're right two variables next to each other, that means they're times. So x times y to the third power. Now we can't just take this cubed times the y because it's closest. These each have an exponent of 1. We have to multiply both the 3 times the 1 here and the 1 here. All right? So that's going to equal x to the third power times y to the third power. And now that we're in 8th grade, we don't need the time sign. It's x to the third power, y to the third power. That's what that equals when we do a power of a product. Now if you want to expand it even more, that would be 3 x's, 1, 2, 3, times 3 y's, y times y times y. And we learned in our other lesson that when we multiply, we add the exponents. 1 times 1 times 1 is still 1, so we have 1x, or just x, to the 1 plus 1 to the third power, times y to the third power, and you end up with your same answer, x to the third power, y to the third power. All right, so that's even written out even into more of an expanded form. Now, in words, the definition, when we're talking about a power of a product, to find a power of a product, you find the power of each factor, each one of each factor, and you multiply. Right? Y is a factor, x was a factor, and y was a factor. You have to find the power of each. In an algebraic model, well, that would be if you have a, b to the c power. I know you guys all like to use the a, b, and c from Pythagorean theorem. That means a times b to the c power. All right, and then that equals, because we have to multiply it, so it's a to the c power, b to the c power. That's what it would look like algebraically. All right, let's do some examples. Let's practice. Example, letter A. Now we need to break this up. Remember, this is like x times y. They're separate, 2 separate factors here. 7 times x to the 1 is x to the 7. And then we have y to the 1 times y to the 7. 1 times 7 is 7. So we have x to the 7th, y to the 7th. Letter B. Now this is like 3 times x, 2 factors here, exponent, the power of 8. We have to multiply this times the 1 and this times the 1. So that's going to equal 3 to the 1 times 8 is 8 to the 8th power, x to the 8th power. Now, it doesn't say if we're supposed to leave our answer in exponential form or not, but if we were to leave it in exponential form, we still have something in this. We can simplify that 3 to the 8th power. We can simplify that yet. That's 8 threes. All right, 8 threes. 8. Oops, threes, my bad. Come on, Mrs. Leonard. There we go. 3, 1, 2, 3, 4, 5, 6, 7, 8. 8 threes. If I were to multiply all those on my calculator, I would get 6,561,000. And then I can't simplify my x to the 8th anymore. So there you have it. 6,561 x to the 8th power. All right, clear my board so I have more room. Now over here we have 3 factors. We have a -2 times an x times a y, all to the 5th power. So I need to take this times a 1, this one, and this one. So I'm going to get a -2 to the 5th power, x to the 5th power, and y to the, because 1 times 5 is 5, y to the 5th power. Simplify our number. That's 5. And this was in parentheses, so my bad, I should have this in parentheses here. 5 and the -2, we talked about that, not letting that. So that's 5 -2's. 1, 2, 3, 4, 5. Now we have an odd number of negatives. So anytime we have an odd number of negatives, we know our answer is going to be negative. And when we take 2 times 2 times 2 times 2 times 2, we will end up getting 32. So we have a -32. And then we still have, we can't simplify this anymore, x to the 5th, y to the 5th. All right, now let's go to this one, letter D. This is 5 to the 4th power times 3 to the 4th power, which equals, well, I can't say 15 to the 8th power. That's not going to work out to be the right answer. So what I need to do is simplify first. Because 5 fours, 5 times 5 times 5 times 5. That would end up giving me 525 times 5, 125, 625. And then 3 times 3 times 3 times 3. Here I get 9 times 9 is 81. And when I multiply those, I end up getting 50,625. Now yes, that is the same answer as if, are these not like terms? Could I multiply these before I do my power out here? Yes, because these are like terms. There's no exponents on these numbers, so I could have gone 15 to the 4th power. 15 to the 4th power. Now if you take your calculator and go 15 times 15 times 15, then you would get the correct answer. It'll still work out to be 50,625. But if you do it this way, if you multiplied, we've been taught to add the exponents, you would end up with 15 to the 8th power, and that is not correct. All right, letter E. We break this out because it's 2 terms, 2 and x to the 4th power. So we have 2 to the 1 times 4 is 4, 4th power, x to the 1st. 1 times 4 is 4, x to the 4th power. Simplifying that, 4 2's, 1, 2, 3, 4. 4 times 4 equals 16. So this simplifies to 16, and I bring down my x to the 4th because there's no other simplifying to do there. Now here we have a negative on the outside. So the negative is separate. That's like a -1, or assumed 1. -1 times 2 times x to the 4th power. Now here my terms are 2 and x, my factors. So bring my -1, that's separate, that's on the outside, times 2, or 1 times 4 is 4, so we have 2 to the 4th power, times x to the 1 times 4, 4th power. Now we simplify, bring down our -1 still, times, what did we just figure out here? 2 to the 4th power equals 16 over here, so 2 to the 4th power, 16, and this stays the same, x to the 4th power. Now when we take this all times a -1, my answer becomes -16 x to the 4th power. Now that's going to be your first day 1 of 3.4. We're going to split it up. We're going to do power of product day 1. All right? So on your worksheet on page 8, I want you to do numbers 3, 4, 5, 6, 7, 8, and 13 on the front. On page 9, I want you to do numbers 15, 16, 19, and 20. All right, again, on page 8, I want you to do 3, 4, 5, 6, 7, 8, 13. On page 9, I want you to do 15, 16, 19, and 20 to go along with this day's notes.